So this is it. If you've followed along with all the videos so far, we're ready to begin our actual climate tree growth analysis, and we're going to do this in the tree climb package in R. So here's how we do it. At this point, you should have downloaded your tree rings from, downloaded your tree ring measurements from the International Tree Ring Data Bank. We did that a few videos ago. You should have verified your cross-dating using COFECHA, so you should have a table of summary statistics from COFECHA, and you should include that in your paper. Then you detrended your series using DPLR in the R package, and you should have a graph like this, which has both our sample size and our ring width index measurements. So you'll want to include that figure in your paper as well. Okay, but now what we're going to do is take those tree ring data, that chronology, and you should have obtained climate data as well. So I have precipitation data here from divisional precipitation data from 1895 to 2016, and I'm using minimum monthly temperature, also from Colorado Division 2. Okay, here's my chronology. So remember, I detrended my tree ring measurements, developed a chronology, and I saved that. So my three main input files for this climate analysis are going to be my tree ring chronology, my precipitation data, and my temperature data. Okay, here's the code that we're going to run in R. And again, you can type these directly into the R console window, but I put them in my text editor here. So as always, we'll start by setting the working directory. So set WD, and I'm specifying the file path of where all my data are. So I have a folder on my C drive called BL460 project1. Then you're going to load in the tree climb package. So you're just going to type in library parentheses tree climb. Then you're going to read in your data. So the first piece of data I'm going to read in is my tree ring chronology. So here I'm creating a variable called GM_CRN. You can name this variable anything you want. And I'm going to, in this variable, I'm going to put in my chronology. So I'm going to use this function called read.table, parentheses and apostrophe or quotation marks. And then I'm going to put the name of my file. So co580crn.txt, that's my chronology. It has here it is over here. It has the year, the ring width index value, and the sample depth. Okay, so I'll read that into a variable called GM_CRN. Then I'm going to read in my climate data. So my minimum monthly temperature, I'm going to call that GM_Tmin. Again, you can name these variables anything you want. Use the assignment operator, and then remember we saved that as tab delimited text. So I'm going to use the read.delim function. So read.delim parentheses, and then I'm going to type in the file name of my temperature data. Do the same thing with my precipitation. So I'm making a variable called gmprcp, read.delim, and then the file name of that one. Okay. Then you're going to do what's called response function analysis. So response function analysis, basically what we're doing is we're saying all of these variables, okay, so my January precipitation, February, March, April, May, June, all the way through the year, and my precipitation, or my temperature, January, February, March, right? I'm saying I'm going to make basically a regression model that says predict my ring width, or predict my ring width index using all of these different variables. And then I'm going to evaluate that regression model to see which of those predictor variables have a significant influence on tree growth. Okay? So it's basically a model development and evaluation process, and that's how we decode what monthly climate variables are important to tree growth. So to do this response function analysis, you're going to need to run this code. From the tree climb package, you're going to use the function dcc, and then you have to tell it what data to use. So the chronology I'm using is gmcrn, that variable I created. So you type chrono equals gmcrn. comma. So commas separate all the little commands that we put into this function. Climate equals, and then I'm making a list. So I'm going to use the function list, parentheses, and I'm going to use my temperature, comma, my precipitation, parentheses. Okay. Then variable names, so this is important for the plot that we're going to make. Type the letter C, and that means concatenate. So C, parentheses, and then in quotes, tmin, comma, precip. Okay, so that's going to tell it what to call my variables. Then this is important, selection. So this is saying what months do we analyze, like the window of months that we're going to use as our predictor variables. And so you see I'm using -6 means previous year June, right? So you number the months 1 to 12, January through December, to 9, which is current September. So you have to think about what's the growing season in the place where you're working. On Grand Mesa in Colorado, it's probably going to be about June to September is going to be the main growing season. So the previous year is usually important because climate variability in the previous year is going to influence the ring for any given year. If there was a wet year prior to growth, it means the tree probably was able to store up more resources and have a wider ring this year. So I'm going from previous June to current September, and you should actually mess around with those and explore your output and see what gives you interesting results. And then my method is response. You can do this with just correlation, and I would say if you run the response function and you don't get any, or you get very few significant variables, then try it with just correlation. You run the same code, except you change method here to correlation. And it's not quite as rigorous as the regression framework, but it'll give you an idea of what kind of variables are associated with tree growth. Okay, so that's basically how we run it. Let's do it, and I'll show you what happens. So I'm going to start up my R window. So here's my R console window, and like I said, you can just type these commands directly in. Okay, so I'm going to send over this. So set my working directory, load in tree climb. I get a little warning message that tree climb was built under a previous version of R. That's not a problem. And then I'm going to send the read table so that my chronology is in there, and then my temperature, and then my precipitation, and then I'm going to do my response function analysis. So you get this little message that it tries to use the overlap. So we're starting in 1895. So the time span is 1896 to 2000, right? That's the maximum overlap between our climate data and our tree rings. Okay, now it's all done and nothing happens. So what you have to do now, make this a little bigger, you have to type plot, and I created a variable called GMRESP. That's where all of this analysis went into. So I'm going to plot, parentheses, GM underscore RESP, and then hit enter, and here are my results. Okay, so it creates this really cool plot, and so you'll notice that precipitation is in the red bars and temperature is in the blue. If you reverse the order or whatever, your colors would be different, but red is the first variable to go in and blue is the second. Significant correlations are going to have a solid line, so basically we have a point and we have standard errors. Actually, no, these are 95% confidence limits around that variable. And if they're dashed lines, then they're not significant. Okay, so if we look at the bottom, so this is, so on the y-axis, these are your regression coefficients, right? So if that regression coefficient is positive, then we have a positive relationship between that variable and tree growth. If that coefficient is negative, it means we have a negative relationship. So again, previous year months are in lowercase letters, so at the bottom here I'm going from previous June through the winter to current January, current September, right? So for precipitation and for temperature. So let's look at the pattern here. What we see, the most obvious thing here is I've got several months in the previous year that are significant. So what this is saying is that previous July, August, September, and October precipitation are significant predictors of ring width, of tree growth, which makes sense. So if we get more precipitation during that previous summer and fall, then the current growing year, right, that ring width is going to be wider. It's a positive relationship. So increased tree growth and increased precipitation co-vary together. Okay. The other significant variable I have is in current year June. So if we have a lot of precipitation in June of a given year, it means that ring width is going to be wide. Okay, and we get our statistical power from the fact that we have replication from 1895 to the year 2000. So we have a lot of data, a lot of rings that independently get tested. Okay, now let's look at temperature. So this is minimum monthly temperature. And so we see a negative relationship here. So when temperature is lower, we get more tree growth, right? Or if temperature is higher, we get less tree growth. It's an inverse relationship because our our regression coefficient is negative. So what this is showing us is if it's in July, if it's cold or cooler, it's because it's July, then we're going to have more tree growth. And if we look back over here, we see previous year July. That's our strongest predictor of tree growth. So basically, a wet, cool July is going to give us a wide ring, and a warm, dry July is going to give us a narrow ring, right? So that makes a lot of sense. So even though this is temperature, what we're really seeing is a drought stress signal here. Now here, in December, we have a significant predictor saying that if we have a warm December, we have more tree growth. Biologically, that's a little tenuous because the tree's not doing a whole lot in December. But what it might be is showing that if you have a warm December, we might have more snow. Typically, if it's warmer, we might get a little more precipitation. So maybe that's a snowpack signal or something. But it's hard to interpret. But what we can see very clearly is that previous year precipitation, and certainly this idea of July being cooler and wetter is probably our most interesting or our most significant predictor of tree growth. So I would run this analysis a few times. I might change the window, the number of months that I use. You could try different climate variables and so on. And then you'll save this graph and include this in your paper and interpret it. If you want information on how this works, check out this paper by Zhang and Biondi that explains the tree climb package. There's lots of information here with how the analysis works, and there's good references in the paper too for when you're writing your methods section. So that's it. We've done a complete analysis going from raw tree ring measurements to an analysis of climate and tree growth.